Welcome to the lecture. In this lecture, we are going to discuss about the PID controller and its working and its application. So before getting into the PID controller, first we need to know the purpose of a controller. So controller is nothing but a device or a process used to control a process undergoing or a process variable we need to make a correct option. So in this PID controller, first of all, we are going to consider a closed loop system. In this closed loop system, we have a PID controller which includes a feedback control system. This system evaluates the feedback variable using the fixed point to generate an error signal. Based on that, it alters the system output. This procedure will continue till the error reaches 0, otherwise the value of the feedback variable becomes equivalent to the fixed point or set point. This controller provides good results as compared with the on-off controller type. In on-off type controller, simply two conditions are obtainable to manage the system. Once the process value is lower than the fixed point, then it will simply turn on. Similarly, it will turn off once the value is higher than a fixed value. The output is stable in this condition of a controller and it will swing frequently in the region of the fixed point. However, this controller is more steady and accurate compared to the on-off type controller. So in this diagram you can see we have an error controller, an error detector and PID individually connected parallelly to one plan process. So here U of t is nothing but the input and Y of t is nothing but the output and E of t is the error signal. These input, output and error signal are returned in the time domain. And let us discuss about the working of PID controller. PID controller maintains the output such that there is zero error between the process variable and the set point or desired output by the closed loop operations. PID uses three basic control behaviors that are explained below. First one is nothing but P controller. As you can see the block diagram here, we have the set point process variable which is compared with an error detector and the error signal is given to the proportional controller and the proportional controller is directly given to the planned process and we get a controlled output. And in PID controller, P controller is nothing but the proportional of P which gives the output that is proportional to the current error, that is E of t. It compares the desired or set point with the actual value of the feedback process value. The resulting error is multiplied with the proportional constant to get the output. If the error value is 0, then the controller output is also 0. And next we discuss about the I controller. Due to the limitation of the P controller where always exists an offset between the process variable and the set point, I controller is needed which provides necessary actions to eliminate the steady state error. So in this block diagram you can see we have a set point and process variable which is compared in an error detector and the error signal is given to the proportional controller where in proportional controller additionally integration part is taken, that is 1 by t, that is the integral part, and after the integral part the control output is fetched. It integrates the error over the period of time until the error value reaches 0. It holds the value to the final control device at which error becomes 0. And next is D controller. So here we can see that we have set point and process variable which is compared in the error detector and this error signal is given to the proportional controller where simultaneously next step is integral part and simultaneously next step is the derivative part. So I controller doesn't have the capability to predict the future of the behavior of the error. So it reacts normally once the set point is changed. D controller overcomes this problem by anticipating the future behavior of the error. Its output depends upon the rate of change of error with respect to the time, multiplied by derivative constant. It gives the kickstart for the output, thereby increasing the system response. And let us discuss about the application of this PID controller. The best PID control application is a temperature control, where controller uses the input of the temperature sensor and its output can be allied to the control element like a fan or a heater. Generally, this controller is simply one element in the temperature control system. The entire system must be examined as well, considered by choosing the right controller. So not only the temperature controller in a control system, but also we have to concentrate on the other parameters also. So other applications like temperature control of a furnace, MPPT charge controller, the converter of the power electronics. In the next lecture we can discuss about the each individual controller and its applications. Thank you.